These are the 2.1 notes. We are solving systems by graphing. So a system is just two equations happening at the same time. So for our first example, it says solve the systems by graphing. Write your answer on the line provided. So we ideally want everything in y equals mx plus b form, because that's what's easiest to graph. So if you'll notice our problem number 1, both of these are already in that format. So we can graph each of those lines. You're always going to start by graphing the y-intercept, the 4. You're going to go up 4 on your y-axis and put a dot. Then for the slope, I want you to think about this, negative 3 over 2, as negative 3 over a positive 2. So we're going to go down, but to the right as we plot our slope. Down 3, right 2, right there. And we can continue that pattern, down 3, right 2. For these particular problems, it's really important to make your long line very long. Extend it all the way across the paper. Even go backwards here, up 3 and backwards 2, up 3 and backwards 2. And we're going to very carefully draw our line here. So the reason we want to make sure that our line is very straight and very long is because we are about to graph another line on the same grid. So this next one, y equals 1/4 x minus 3. We're going to graph it on the same graph. We're going to go down 3, put a dot. Then we're going to go up 1 and over 4. Up 1 and over 4 puts us right there. Up 1 over 4. And same thing, just keep following that pattern. Down 1 and back 4. And then you get two lines drawn on the same graph. What you're looking for, what your solution is a place where your 2 points cross. So this point right here at 4, negative 2 becomes your solution. So your solution is 4, negative 2. It's the point where the two lines cross. Okay, let's look at our next example. Problem number 2. Y equals 3x plus 2. That's ready in graph form. It's in the slope form, y equals mx plus b. I'm going to go ahead and put this over 1, so that way it looks more like a slope. Take a moment and graph that equation, y equals 3 over 1x plus 2. So we start at positive 2 on a y-axis and go up 3 and forward 2, forward 1. Up 3 and over 1. Likewise, you can go down 3 and backwards 1. Notice it's part of that same line. Down 3 and backwards 1. And extend that line nice and long. For our next line, I notice that it is not quite set up to be in the same format as our y equals mx plus b. So we're going to make sure that we solve for y. We did this last chapter. Subtract 4x. In order to put it in the y equals mx plus b, I'm going to put the negative 4x first, and then that positive 9 at the end. Because I'm going to graph it, I'm going to put my slope as negative 4 over 1. Graph that line, and then see where your two lines intersect. You should have started up at 9. Then you're going to go down 4 and right 1. Notice that the 1 is still positive, so you're still going to move to the right. Once again, you'll notice that you have a point where each of the two lines crosses or intersects. That becomes your solution point. That's the place that makes both of the equations true at the same time. See if you can name that yellow dot. See if you can name that point. We name our points always how far to the right or left we went. So I went from the center, I went forward 1, and then I went up 5. So my point is 1, 5. Okay, so there's two special cases I want to talk to you about on the other page. So we're going to talk about the special cases once we get there, but in the meantime, we're just going to go ahead and graph as normal. So this first one, y equals negative x plus 3, is already solved for. You can think about writing this as y equals negative 1 over 1x plus 3. We can always put a 1 in if there's nothing there in front of the x. Take a moment and graph that on your graph, please. Should look something like this. Start at positive 3, and then just go down 1 over 1, down 1, forward 1, down 1, forward 1, and up 1, back 1 to continue the line. All right. Something like that. Okay, so then I'm going to go ahead and work on the other line up here. This one is not in slope-intercept form, this 3x plus 3y equals negative 6. So I'm going to need to solve for y. If you remember how to solve for y, almost like we did on the last one, go ahead. When you solve this all the way out, you should have gotten y equals negative 1x minus 2. So what I'll do is I'll now graph that line. Start by going down 2 on your y-axis. And then, just to make sure you're focused on the rise over run, put that 1 over there. You're going to go down 1 and forward 1, down 1, right 1, down 1, right 1. So the thing about these two lines is they are parallel. We talked about parallel lines last chapter as well. But if these two lines are parallel, then the lines never cross. And if they never cross, then we can't possibly have a solution here because the solution is where the two lines cross. So for our answer, we write no solution. They cross nowhere. All right, so that's one of our special cases. Let's take a look at the last example, and we'll see our other special case. So it looks like, again, our first problem, our first equation, y equals 2x plus 5, is already ready to be graphed. You might want to think about adding a 1 underneath that 2. Take a moment and graph that line, please. You should go up to 5 and put a dot. And then up 2 and forward 1. And down 2 and backwards 1. And as you go the opposite direction, you should still have that exact straight line. It shouldn't look like it's curving or that it's bent anywhere. If it's bent, it means you made a mistake. All right, that line was a little off. I'm going to redraw that. Here we go. That looks better. Okay, so my first line is drawn. Now it's time to look at my second equation. This is another one where we're going to have to solve for y. So take a moment and get y by itself. I'll do the first step for you. Okay, so when you solve for y, you should have gotten y equals 2x plus 5. Because we're graphing, I'm going to put 2 over 1. And I'm going to go to my graph. I'm going to go up 5 and put a dot. That's interesting. Then I'm going to go up 2 and over 1. Up 2 over 1, down 1, back 1, down 1, back 1. And it looks like I'm creating the exact same line. The pink line is going right over the blue line. All the spots are the same. All the points are crossing. So if it's the same line, they cross everywhere. And so you're going to write the phrase, infinitely many solutions. There are a ton of solutions. So I like the word infinitely. So I often refer to it as IMS, infinitely many solutions. So I just shorten that. You could also just write the phrase many solutions, and that would also be accurate. So those are your two special cases. One where they never cross, you get no solution. One where they are the exact same line and they cross everywhere, gets you infinitely many solutions. All right, nice job today. If you have any questions, let me know.